So now that we have our basics set up, let's talk a little bit more about how we can check different conditions. And we're going to go through a couple different possibilities and expand our system just a little bit. So first, I mentioned earlier how on some of these, we're checking OnTick. So for example, OnTick, go to rising, and we're looking at a variable every single tick frame. That's usually not good practice. And instead, I just want to send a notification out for this to listen to instead of every frame. And that notification will trigger anytime our actor count has changed. So anytime our actor count changes its value, we can send out the notification and then we'll do our check. It's just a cleaner way of building up a trigger system. And I want to show you how it is possible inside of the state tree system. So we're going to do that. Let me actually type out our options here, things we're going to cover. We're going to do for checking conditions. So far, we've been doing OnTick. This is pretty common. We've also been doing onStateCompleted. I want to show you OnDelegate. What this is going to do is allow us to trigger a specific notification. So trigger in a notification. And this way, at some point in our task, we can leave a little hook that our transitions can listen for. And if we get that little trigger notification, then we can check our condition and try to transition. So for example, in this case, I'm going to build a delegate to trigger whenever our actor count is changed instead of just watching the integer value. So let's do that and see how to set it up. I'm going to return to my state task for get overlap actor count, and I'm going to make a new variable down here. So it is very possible that the system could change in future versions of state tree. As of 5.6, this is how we can make our delegate broadcast. I'm going to make a variable that we can listen to and that we will send out the notification on. So if you hit plus on variable, I'm going to call this on actors changed, and I'm going to change this to a type called state tree delegate dispatcher right here. So other things can listen to this, and this will send out a broadcast, and anything listening to it will receive the notification and respond. So if I compile and save, I can show you how we will use this. So whenever you make a delegate like this, you need to broadcast it at the appropriate place when whatever you called it, on actors changed. So to do that, we're going to go inside of our get overlap count. And in order to detect if our actor count has changed, we're going to slightly modify our logic here. And we're still going to get the length. But before we set it, so I'm going to disconnect this pin. Before we set it, I'm going to drag this over here, this overlapping actors. We're detecting the length. And before we set the new amount, I'm going to check to see if the new amount is different than the current amount. So to do that, we're going to get our actor count. So get that. So this is the current amount, and we just received our length. So we can test the two. We can say, is the last time we set the actor count not equal? So exclamation equal. If it's not equal to our length, then our actor count has changed, right? Because we have not set the new amount yet. So if it's changed, let's do a branch. So we'll do our branch, hook it in, pull this up a little bit. Let's move this around, make it a little nicer. Pull these out. Okay, so if our actor count and our length are not equal, and that's true, then our actors have changed. So we're going to pull our onActorsChange delegate in here. So this is how we broadcast. This is sending the event trigger. We're going to pull off of onActorsChanged and say broadcast. So we're going to broadcast delegate. And so off of this true, so if our actors change, we say true, broadcast it, and then continue to return. If it's false, we don't want to broadcast a delegate, but we still do want to continue. So we're still going to set it. And actually, I did this wrong. We're going to connect to the set because we want to set the new amount either way. Double check all this. I think this is fine. Let's move this over a little bit. So I think this is good. So all we've done is created a state tree delegate, and we've broadcast it when it is true. So when our actors have changed, and this will get hooked into by our transitions. So let's compile and save. Let's go back. Let's test it out. Go to our state tree weighted platform, go to our idle, and instead of listening to OnTick, I want to show you the slightly modified way of doing this. We're going to change this to OnDelegate. Now, because we set up our delegate inside of our task right here, this onActorsChanged, we can see that with our delegate right here. We go into get overlap actor count and we go to onActorsChanged. So anytime this receives a broadcast, it will run down here, check the condition, and if it's true, we'll make our transition. So it's just a slightly better way of not using OnTick and instead of waiting for a specific trigger, which is kind of nice. So I'm going to set this same thing up for syncing. I'm not changing the condition. I'm just changing the trigger to OnDelegate and then change to OnActorsChange. Okay, so that's our trigger. Everything else is the same. Our transition to and our condition. Same thing for rising. So go to rising, change OnTick to OnDelegate, assign the delegate to OnActorsChanged, compile, save, and let's try it out just to make sure we didn't break anything, but I think it should work. So idle. Okay, we got the notification that our actor count has changed, so we check it and we start syncing, we start rising, syncing, rising, check the other one right inside there. Okay, and this one doesn't sync as low. Okay, perfect. All right, so this is working, and I just wanted to show you how you can use delegate triggers for more specific control rather than checking a value on tick. Certainly there are reasons why you might want to do that or why it can be powerful, but this is another tool that you can use to trigger your transitions. The next thing I want to show you is called interconditions. So inside of state trees, what we can do is we can lock a certain state behind some conditions so that if these conditions aren't met, then we will never enter the state. So there are a lot of ways to use this. The way that I'm going to show you how to use this is we're going to make a deactivated state and we're going to check a isActivated variable on our weighted platform. And if we turn it on or off, then we will look at that to determine if we should stay in our deactivated state. So it's going to be a little bit different than idle. And the way that we're going to do this is we're going to put the state right above idle, and we'll have an intercondition for deactivated. We'll say, if we are deactivated, then enter this state. If not, go down the tree, which idle will be next, and then we'll just do our normal thing. So let's do that. The first thing we're going to do is we're going to add our variable. And this is something we could set at runtime if we wanted. So we could have like an interactive switch that can turn on and off platforms. For now, we're going to track that with a variable. So add a new variable. We'll call this isActive. We'll change this to a Boolean. We will make this instance editable because each individual platform, this one might be activated, this one might not, this, and so forth. And let's compile, save, and let's make this default true. So by default, we are active. I think that's reasonable. Compile, save. And let's come over here and we're going to turn this third platform. We're going to mark this variable that we made as false. So we're going to assume that this third platform will start in the deactivated state, which we're going to set up next. Okay, so we're marking that variable false. The next thing we need to do is we need to make our deactivated state. I'm not going to get too complicated with this. I'm just going to right click, add a child state. It appears at the bottom. We're just going to click this and then just redrop it in so it comes at the top. The important thing is that this order matters. So when we start a root, we're going to check one by one. So if we don't meet this intercondition, we're going to go to the next one, which will be idle. Now, if idle was down here, for example, then we would actually go to syncing next, and we would need interconditions to check for that, and then interconditions for rising. I'm going to bring my idle back. I actually do want idle to be the next thing after deactivated since we're using a hierarchy type of structure here. But I do want to point out that the order does matter. So we're going to test deactivated. And if our interconditions aren't met, then we're just going to go to idle. Again, you could set up a lot of interconditions for all these different states. I'm just going to keep it real simple, and idle will just be my default after some things I check at top. Let's relabel this top state as deactivated. And we could make child states, like if we wanted a deactivated sequence or something, but I'm okay with it. I'm just going to keep this as one state just to keep everything simple. And we're going to add a intercondition for deactivated. So make sure you have it selected right here. Intercondition. So this will act kind of like a guard and not allow this state to be entered unless these conditions are met. So we're going to do a Boolean compare, and we're going to compare that new variable that we made on our actor, the isActive. And if isActive is false, so it's not active, we want to enter this state. So it's going to try it one by one until we can enter one. And if we're not active, then we should go to deactivated. And while we're in this state, again, I'm going to keep it real simple. We're just going to do a delay. Let's say delay task. And the way that I'm going to set this up is I'm going to delay every 1 second. I'm going to complete the state and then return to the root. And what this is going to do is it's going to every 1 second return to the root and then keep checking. And as long as we're deactivated, we're going to keep entering the state. But if at some point during runtime, our active changes back to true, then we won't. We'll go to idle. Now, the reason I'm doing it this way is because this is a really handy pattern for just sitting in some kind of state, but periodically checking to make sure that, we're in the right one. If I put a delay run forever loop, we would never exit deactivated, right? We'd have to specially call a transition to get out of it, which we could do. Like we've already talked about other ways to do that as well. But I just want to show you this pattern because it is kind of common in AI to just like wait here for something to happen, like idle or whatever. So anyways, delay, and then we are going to return back to the root once we're done, right? And we're doing that automatically. I'm just going to be explicit about my transition here. So we're going to say on state completed, return to the root. So I just added a new default one. So we will return to the root, check if this variable is false, then we'll go to deactivated. If not, then we've turned it back on and we'll go to idle. Let's compile and save. And one other thing that I'm noticing when we're rising, we actually don't want to return to idle, right? We want to return to the root because we do want to check the interconditions. So this is something that I had set up previously that now with our new structure, we have to change. So hopefully this makes sense. If we go to root, we're checking all of our interconditions like top to bottom, and it's just a slightly different structure. So let's go to rising, and this bottom one, on state completed, don't return to idle, return to root so that we can still check our deactivated before going to idle. So go to root. Okay, so after we're done rising, go back to root. Now, the reason this works is because syncing and rising are kind of part of a sequence tied to idle. We could group all of this under some activated state if we want and, further expand this. But again, I'm just trying to keep this very simple and visible. File save, and let's test it out. Remember, our third one is not active. We marked it as active false. The other one should be true. So let's try it. Play. Okay, this works. This works. You can see this one does not work at all because it is marked not active. So it looks like it's working. Now, the reason I wanted to show you interconditions is because this is especially useful for AI setups. You'll see this a lot. Anytime we want to make a decision on which state to use, we probably want some kind of intercondition. But if we want to make it more rigid and specific and, more like a sequence and do very specific transitions, then, we can set it up how we did before without the interconditions. It just depends on what you're trying to do with it, right? Like if you want to check a series of things, or you could wait for specific transition conditions. They're just two different ways to set it up. And I thought it would be important to show you both. Next, we're going to look at a way to use categories and colors to clean up our state tree a little bit. Because right now it's fine, but eventually I may want to use colors to separate different kinds of states. So for example, I may want deactivated to be red and anything associated with syncing to be a certain color. Just really handy to be able to color code some of this stuff. And it's really easy to do. Down at the bottom on the left, we can define the colors associated with categories inside of our theme dropdown right here. So if I want to do that, let's expand theme. We're going to add a couple more colors. Let's add one for deactivated, syncing, and rising. Okay, so I'm going to label these. We'll just keep a default color. That's always nice to have. Let's also, the second one, we'll make that deactivated, and let's make that red. So anything associated with the deactivated state will mark as red. Next, anything with syncing, we will change that color, maybe something like yellow. And then the last one is rising. Okay, we'll make this one green. Okay. So these colors don't really matter. The point is these colors are associated with this state tree, so you can make them very specific if you want. And we just need to assign these to mark each of the different ways that we want to use it. So deactivated, we're going to come over here. On the top right, the color, you can see if you hit the drop down, it associates it with the colors that we made over here. So we'll mark that deactivated. For idle, we'll keep that default. We could always make a different color for that, but I think default is fine. For syncing, I'm going to shift select all of the states in there, and just to show you can do it, you can do multiple at once. Assign that to syncing. That's a little bit hard to read, but we'll just keep it for now. Rising, let's associate that with green. And, I'm going to tweak this slightly just to make it a little easier. Okay. And you can see it updates over there, which is kind of useful. Okay, so we tweaked our colors. So compile and save. And as you can see, this is a little bit easier to read and will help us if our state trees get a lot more complex. We can just very quickly look at it and see the color association. Even better, if you look at the transitions over here, when we choose a transition, it will actually color code it inside of this little drop-down menu to make it even easier to see where we're going. So that's just very useful. Now let's talk about delays, because something I'm noticing with my platforms is when I transition from syncing to rising, it's instant, right? Now, maybe you want that, maybe you don't, but what I want is I want there to be a slight delay between the syncing and rising. So we're going to look at two different ways to do that. So when we're talking about delays, we have a couple options here. We've looked at the first one, which is our delay task, and we could find a way to use that. But another option we have is our delay transition. And I'll show you where we can use this and the pros and cons of it. And the last thing I'm going to show you regarding delays is how to use child state delays to just give us further control. And we'll, again, talk about the pros and cons of all of these. So delay tasks we've already been doing, right? We've set up delays, for example, inside of our deactivated to check, to go back to root. We've used delays forever, right? But what I'm going to do is when I'm syncing and doing my check to go to rising, you'll see this little option right here, delay transition. This means that we're going to continue doing that. Like, we're going to trigger our transition, but we're going to wait for some amount of time. So I'll check that. And we can say delay duration, maybe 0.3. So we're not going to start our new state until 0.3 seconds. Now, there's a big difference between that and going to our state and then delaying for 0.3 seconds. So I want to show you what that means. Compile and save. So we have our delay transition under our switch between syncing, transitioning, and rising. If we delay by 0.3 seconds, we're going to keep moving down for 0.3 seconds, right? Like when I jump, it moves down a little bit more before rising. I think I like that for my design because it helps prevent the player from just permanently hopping and, right, like we can't just keep hopping on the platform and it just never goes anywhere. The reason why this is different is we are continuing this current state for another 0.3 seconds and then transitioning instead of transitioning immediately and delaying in the next state. So this happens before the switch, but I actually like the way that it works out right here. And you could add some random variants if you want to do that, but I want to keep mine at 0 and just use it as is. So the next thing I want to do is I want to add a slight pause at the top of my platform. In a lot of games, whenever we're running across these syncing platforms, we want it to like shake and play a particle and a sound effect before we start syncing, right? We're cueing the player that something is about to happen. It doesn't just happen instantly. Now we could put our delay transition like we did on the other one, but I want to show you a different way to do it. I'm going to make a child state called start syncing, and we're going to transition immediately into that. And because we're making that a separate state, we have a lot more control. Like we can put additional tasks on it. So for example, previously we did this delay transition. We can't really do anything past that. We can't assign special tasks during this delay. But if we were to come up underneath our syncing, and I'm going to make a child state, let's drag it back up to the top, well, underneath right there. And I'm going to call this start sync. I'm going to give it the color just to keep it clean. For this one, I'm going to add my delay task. So go to our task, go to delay task, and we're going to put the slight time we want to wait. We'll do 0.3 again. I think that's a good default. And then when we're done, we want to make sure that we transition. So hit transitions on state completed, meaning that our delay happened. We're going to transition to move. So we're going to start syncing for 0.3 seconds and then go to move. Now the difference here is because this is a separate child state, we have a lot more options compared to the other one where we're just waiting before our transition. So we could play a special sound effect here, which we'll do later. We could play special particles. We could, shake the platform a little bit. We could do a lot more stuff. So this gives you more control by putting it in a separate child state compared to the easy and quick delay transition. So if we compile and save, we're going to start our syncing. It'll start at the top. We'll pause for 0.3, then we'll move. We'll wait. We're waiting for this transition, and we'll still have our delay before our transition right there. So let's test it out. Let's go over here. Okay, cool. So one big difference here is you see we're waiting while we're in our syncing state, right? But the delay transition, we are waiting while we're still in the syncing before we go back to rising. So it's kind of a subtle difference. And if you didn't like that, like if you wanted it to pause while we're syncing before going into rising, like right now I'm continuing to sync for another 0.3 seconds. If you wanted to pause there, you could always make a start rise child state like we did up here. But I'm not going to do that because I just want to show you both methods and just the pros and cons of each. And that'll be especially clear later on when we start adding additional tasks and particles and things to some of these states.